contract. This topic will take at least 2 or maybe 3 weeks to cover. Option market convention. Option contracts have been traded for centuries. Customized option traded on over-the-counter market. In April 1973, standardized option began trading on the Chicago Board Option Exchange. The fundamentals of option valuation, risk reduction tools when used as a hedge. Forecasting the volatility of future asset prices, direction and magnitude. Hedge ratio is based on the range of possible option outcome related to the range of possible stock outcome. Risk-free hedge buys one share of stock and sell call option to neutralize risk. Hedge portfolio should grow at the risk-free rate. The basic approach. Here we assume that WYZ stock price as the following. Assume the risk-free rate is 8%. Want the price of a call option CO with exercise price. X means here exercise price 52.5. Stock price now is 50, and we expect price in 1 year from now to be 65 or 40. Binomial option pricing model. This is the first trial to price an option. Two-state option pricing model, up movement or down movement, forecast stock price change from one sub-period to the next, starting from known stock price today. The most important model is Black-Scholes valuation model, a model for determining the value of American call option. Prices can also change continuously throughout time rather than discrete. Assume that stock price movement can be described by a statistical process known as geometric Brownian motion. This work warranted that awarding of the 1997 Nobel Prize in Economics. So it is very important. Please note that Professor Black and Professor Scholes, the first to make this model. Black-Scholes model pricing formula. We start by estimating D1 and D2 CO call price. Call. They priced call, not put option. Call S ND1 minus X E raised to power minus RF risk-free rate times T ND2. I will explain all these terminology. S means stock price now. ND1 is the normal distribution of D1. X is the exercise price, and E exponent minus RF, risk-free rate, times the time period of the contract, times ND2. How to find D1? Here is the equation. D1 is the natural logarithm of S divided by X plus the risk-free rate plus 1/2 sigma squared times T, all divided by sigma square root of T. D2 is D1 minus sigma times square root of T. Here is all the definition of these terminology. Properties of the model. Option value is a function of 5 variables. Current security price, which we call it S, exercise price, which we call it X, time to expiration, the period of the contract, risk-free rate, and security price volatility measured by standard deviation. Hence, the call price is a function of these 5 variables: S, X, T, risk-free, and sigma. This example, consider the following values for the 5 input variables. S is equal to $40, X also $40, T 1 year from now, risk-free is 9%, and sigma 0.30. To calculate the Black-Scholes value of European style call option, European, not American, call option under this condition, we compute the input variables. D1, natural logarithm of 40 divided by 40 plus risk-free 0.09 plus 1/2 0.3 square, sigma square, multiplies by 1 year, divided by 0.3 square root of T, which is equal to 0.45. Hence, D2 is D1 minus sigma times square root of T, 0.45 minus 0.3, 1 year raised to power 1/2 means square root of 1 is equal to 0.15. To find ND1 from the equation or from the table of normal distribution, ND1 0.6736 and ND2 is 0.5596. To compute the option value, the call option is 40 times ND1, which is 0.6736, minus exercise price 40 times E raised to power minus 0.09 times ND2 0.5596, which is equal to 6.49. Hence, the call option of this example is 6.49. Here is the relationship between call option and stock price. as we see. According to Black-Scholes value, take this curve. However, intrinsic value is a straight line starting from 40, the current price of the stock. The question now is how to estimate the volatility or the standard deviation of return to the underlying asset can be estimated in two ways. The first approach is the traditional mean and standard deviation of a series of price relatives, as we have done with the portfolio, if you remember. The second approach is to estimate the implied volatility from the Black-Scholes formula itself. Problem with Black-Scholes valuation, stock prices do not exchange continuously. Arbitrageable differences between option values and prices due to brokerage fees, bid and ask, spread, and inflexible position size. A risk-free rate and volatility level do not remain constant until the expiration date. Empirical studies showed that the Black-Scholes model overvalued out of the money call option and undervalued in the money contract. Any violation of the assumption upon which the Black-Scholes model is based could lead to a misvaluation of the option contract. I think this is what we need to know. However, we can continue some other example in the future. Okay, thank you.